Hello boys and girls, today we'll talk about similar figures and scale drawings. So these two are the main applications of the ratio. For the first one, similar figures, you should learn one of the similar figures in Form 1. Okay, remember similar what? Similar triangles, okay? So we'll do some revision on the similar triangles and we'll go further to similar figures. The next one is the scale drawings. Where can you find the scale? Yes, from the Google map, you may have this one at the bottom of the map, maybe 5 km. So what is the meaning of this kind of the interval here? It means that, for example, 1 cm in the map equals 5 km in reality. In real, it's 5 km. Or if you pay the model Gundam, you may have this one 1 to 144, 1 to 100, or 1 to 60. So these are the scale also. Okay, 1 cm equals 144 cm in real. Okay. Okay, let's talk about the similar figures first. Before we talk about, let's have some quick revision on what is the similar triangles. Similar triangles are the triangles with the same shape. For example, we have the triangles like this one. Okay, 3, 4, and 5. So equal shape. Equal shape. And all the angles are equal. Equal shape, equal angles, and what are the properties? The last one is 3 sides proportional. With corresponding sides are proportional. With PROP, the short form. So for example, this one is the 5 and then we have 10 here. So this is the corresponding side. How about the height? This one is the double, 5 to 10, 5 times 2. And then 4 times 2. The height becomes 8. The last one is 3, also times 2. We'll have 6 here. So proportional, this word, that means in ratio, okay? So this is the similar triangles, some kind of the simple idea or concept from the similar triangles. And now we go to the similar figures. It's nearly the same, okay? Also, we have this kind of the properties here, okay? Equal shape, equal angles, and corresponding sides are in proportional. So in other words, that means if I have the rectangle here, when I do the enlargement, for example, what do you mean by enlargement? Just we use the, for example, magnifying lens from again, and again we put on top of this, we may have the larger rectangle here. So this is 2. After we do the enlargement, is 4. This one is 4. When we do the enlargement, is 8. Okay? And remember one thing. All the sides must be in the same ratio. If I draw a diagram like this one, maybe some of you ask whether this one maybe I use this one. Two, 4 maybe becomes 2, 8. This one is not similar, although it looks like it's enlarged, but only the length gets enlarged, but not the height or not the width. And this one is not similar. We need to have the length and the width also get enlargement. So instead of the enlargement, what about the reverse? From the large to small, how do I call it? I hope you remember also is reduction. It's the same, smaller, okay? So this is the shows you the meaning of the corresponding size and how do we form the ratio. Consider the names of their corresponding size. So it shows the color here. This one corresponding with the width, and then the length is corresponding to the length. And then the ratio would be 1 to 2. Okay, 1 to 2. And this is what we call the ratio of the corresponding lengths. Okay. So this one is our conclusion. In similar figures, all the lengths of all the corresponding sides are proportional. Remember, it's all. Okay. So if I ask you whether this one is it a similar figures, the answer is no. For example, this one, the base, is not in the corresponding ratio. It's not in the correct ratio. So this one not in ratio. Well, what we have, we should draw something like this one. Okay, and then this is correct. Okay, so let's look at some example here. So example 1, example 13 from your textbook. So there are how do you know whether they are similar or not? The keyword is the questions will tell you. A, B, C, D, and P, Q, R, S are similar quadrilaterals. If we don't have this word, we don't know whether they are similar or not. Based on the pictures, we may not know. Even some of the lengths are corresponding, but what we need is all the lengths are in the same ratio. So that's why if maybe 3 pairs of lengths are in the ratio, but maybe the 4th pair are not in the same ratio, so we cannot conclude that's whether they are similar or not. That's why we have to read the questions. In most of the situations, questions will give you whether they are similar or not. So this one, yes. And we can find out the ratio we can use the ratio to find out the lengths easily, just like the corresponding size in the similar triangles. So let's look at which pairs do we have. We have the ratio of 15 and a 10. And then we have so that's why we can use this ratio to help us finding the second pair. For example, 15 over 10 So the larger side over the smaller side for the first pair, and the second pair we also use the larger side over the smaller side, which is b over 8. And then 12 here. So on the other hand, we can also use this ratio to find out the third pair, which is 9 and 8. Okay, see, how do we do it? 15 over 10 equals 9 over 8. And then we can just simply multiply crossly. 交叉相乘. 15a equals 90. And then a equals 6. And that's it also. So you look at my demonstrations versus the example solutions. What a difference. So they use the smaller one, 10 over 15, smaller over the large one. So when the second pair, they also use the smaller side over the larger side. Okay, but in my demonstration, we can do the reverse. I use the larger over the smaller, and on the right also we have to use the larger over the smaller. So both are okay, which one over which one, it doesn't matter, but you have to follow. Okay, make sure the ratio must be in the same order. Okay? If you use smaller over larger, then you have to use smaller over larger. Keep using it. But if you use the larger side over the smaller side, then you have to keep using the larger over the smaller. Okay. Okay, after we talk about similar figures, we'll talk about the second application, which is the scale. So it's the scale of the drawing is the ratio of the certain length correspond to the corresponding length of the real object. And most of the situation is expressed in the form of 1 to n. Okay. And most likely we'll talk about the scale drawing is either is reduced, but sometimes is enlarged. Okay. So let's see what is the meaning of the reduced drawing, or what's the meaning of enlarged drawing. Here is this one, the reduced drawing and enlarged drawing. Reduced drawing. So this is the common drawing that we have, because the airplane is too large. So that's why when we draw it, we draw a smaller picture. And actually the scale is 1 to 1100. So what's the meaning? That means 1 cm represent an actual length of 1100 cm. Okay, the units are the same. 1 cm to 1100 cm. Okay, when we do the comparison, we always use the same unit to compare. Okay. And the next one is the enlarged drawing. Enlarged drawing. That means the ant is so small, but when we draw it, we enlarge it and then draw the larger picture. So it means that 1 cm, this one, 1 to 0.1, 1 cm in the drawing means the actual length of 0.1 cm. So for example, if I draw 10 cm, that means what is the real length of this ant? It's just like 1 cm. Okay? So here are some conclusion. the reduction of the real object and the enlargement of the real object, it depends on the scale. And the reduction is the most common stuff. We use, for example, every day we use Google Map. This is the reduction. But when you do with the science textbook, for some species, for example, bacteria, very small, and when you use the microscope to look at it, it is an enlargement. Okay. So the scale means this one, 1 cm, 1100 cm, 1 cm equals 0.1 cm. And actually we mainly use this one. Just compare it with the same unit. Okay. In short, we simplify it by the same unit. Okay. So finally, we come out to the final conclusion is, what's the scale? How do we calculate the scale? The scale equals the distance from the drawing, the length in drawing, over the actual length. Okay, this is the formula. Or if you understand the meanings, actually don't need the formula to calculate the scale. Okay, let's look at example 15. So the length of this scale is measured to be 5.5 cm. So this one, the length is 5.5 cm. And then what's the actual length of the airplane in meter? So the keyword is this one. So how do we find the actual length? So that means it's enlarged by 1100 times. And then we have found the actual length. So 5.5 times 1100. And then the answer should be 6050 here. So what is the unit here? Is cm. But read the questions. It's not cm as the final answer. Should be meter. So we have to over 100. So it becomes this one over 100 meter. So 60.5 meter. Okay. So when you write down your steps, make sure you write down the unit and read the questions carefully whether this one is the final unit or not. If not, you have to do some modifications and then change to the units that's required by the questions. Okay. Alright, example 16. This is the diagram of a Buddha on Lantern Island. The height of this Buddha is 6.6 cm, and then the actual height of this Buddha is 26.4 meter. So with the units again, when we want to compare in the ratio, we should have the same unit. If the units are different, we cannot compare them in the ratio, and so same as the scale. And this question, we want to find the scale of this drawing. So first of all, how do we form the scale? Let's recall the formula of the scale. It's the distance in the map or distance in the drawing. The drawing distance over the actual distance. Okay. So what we have 6.6 over 26.4, and the units are different, cm and m. So the m has to multiply by 100. Okay, and you can use the calculator to calculate. So the answer would be 1 over 400 here. So the scale, we just write down the conclusion in this form. The scale is 1 to n form, 1 to 100 here. Okay. So most likely we choose the same unit. We used cm to do our calculations. With cm also. Okay. Let's look at part B. The Buddha is built on a base of height 7.6 meter. If the base is drawn with the scale obtained in 1 to 400, find the height of the base in the drawing. So this one is not the actual. We are going to find out the drawing in cm, the height. So let's recall the scale. So the drawing versus the actual. So now we have 1 to 400. And now the questions. It comes to the question part. We want to find out this one. And then we know the actual is 7.6. 7.6 meter, if I convert to the cm, which means 760 cm. So what will be the drawing height in this one? So 400 cm equals 1 cm. And now we have 760 cm. What's the height in the drawing? What's the cm in the drawing? So basically just the division, because for actual to the drawing that means becomes smaller. Okay, example 15 is about enlarge, so we multiply and becomes smaller, we use the division. So the height of the base in drawing. This one is 760. Maybe I'll write down the detailed steps. 7.6. Change it to the cm first. And then reduced by using the scale. So over 400. And then we can find the result. So 1.9 and cm. Okay. So I hope you can understand the concept. Why this one is division. Why this one is multiplications. Actually based on what you have to find out. Okay. So you have to understand the situation is enlarged, or you want to find out the drawing distance, whether reduction. Okay. So actually this one we don't have a certain formula to solve the problems in this chapter. You have to understand the concept. If you understand the concept, everything is simple. You don't have to memorize lots of stuff here. Okay, let's look at example 17. So this one is the scale 1 to 200,000. use a ruler to measure distance between central and Sharky 1 and estimate the actual distance here in kilometers. Okay, so this one, the scale means 1 cm to 200,000 cm. So we will use a ruler to measure it from the textbook. This one should be 4 cm. Okay. So 4 cm in a map. How about the actual distance in reality? So we can write down actual distance equals 4 and then times 200,000. So what we have is 800,000 cm. And how you have to change the cm to km. So what should we do? 100,000 you have to over 100. This was to the meter, and then over 1,000 to the km. So that's why cancel 20 and then cancel 30. The last part you have 8 km. Okay, so we will over 100 is cm to m. Over 1,000 is m to km. And that's it. Example 18, the last example in this chapter. So to find the actual length and the width of the flat in meter. So we have the scale here 1 to 80, and this one is the map. Also, this is the distance from the map or the distance from the drawing. So how about the actual? We have to multiply it here to find the actual. 6 about the length is the 6 times 80. And the answer for it is the cm. So we have to convert it to the meter by dividing by 100. Also 3.5 also times 80. We get the cm and divide by 100, we get the meter. So this is the actual length. So you understand the situation. If you do the division, then the length will become very, very small, which is impossible. The actual length must be larger, must be very large. So you understand. Use your common sense and then you see whether this is multiplications or divisions, actually. Okay. So let's look at part B. Part B is the monthly rent for this flat is $5,000. And then 1 meter square, the rent is $350. So is the claim correct? Explain your answer. So we have to find out what's the area of this flat in order to calculate the total rent of this flat. And to find the actual area, remember we use the actual length. If we have the actual length, of course we have the actual length to talk about the rent, to talk about the area. So the actual area, we can find out 13.44. And hence we can use the monthly rent to calculate the rent per 1 meter square. So which is 5,000 over 13.44 to see what's the range per meter square. And finally, we show that the range is $372, not $350. So we can say that the claim is incorrect. Okay. Remember, for the EYA, explain your answer questions. You have to make a comparison here. Comparison. If you want to write down the reasons, if you want to write down what's your explanation, actually it's for the comparison, and also the title, the weight. Okay, or you can write down the range per meter square. Also, it's okay. The alternative of the title. So this time we have the classwork for 12 questions. So this chapter is quite long actually. So try to finish all these 12 questions maybe in 20 minutes. And then again finish it on a single line paper and upload it to the Google Classroom. So on Wednesday, the live lesson, we'll do the summary on the whole chapters and see whether you have some questions to ask or not. There are many teachers join our lesson, so you can feel free to ask and see them. Bye.